about the perimeter and area of similar polygons. We're still dealing with perimeter and area, but we're not going to be dealing with like straight from the formula. We're going to be dealing with the fact that the idea of the shapes being similar, and so it's going to have to do with scale factor and some other things as we go forward. You'll see this. Let's go ahead and get started on this. So first of all, if the scale factor of two similar figures is, and then you're going to see this out here. So guys, look at this. You've got these two shapes. They're similar. They're telling you they're similar. That means they're the same shape. They're just different sizes. If it has a piece right here that's 8 and a piece right here that's 4, the scale factor of these is going to be the relationship between them. So it's the ratio of the, guys, ratio just means fraction. Okay, don't make it harder than it is. The ratio of the perimeters and the ratio of the areas, again, a fraction, is what we're going to be looking for. So we start off with the scale factor of it. The scale factor is just going to be the side on the left to the side on the right, unless you tell you otherwise. You always go left to right just like you read a book. So it'd be 8 over 4. That's it, guys. 8 over 4, and we reduce it. Now it is a ratio, so don't reduce it down to a whole number. Please make sure it stays a fraction. Because it is a ratio, it's going to need to stay a comparison to two numbers. So what would 8 over 4 reduce to? 2 to 1. Perfect. Right. Whatever that scale factor is, the ratio of the perimeters is going to be the same. So I'm going to write same as scale factor. Guys, you don't have to find it. It's exactly the same as the scale factor. So if you have a scale factor, which we already have, it's 2 to 1. This one is twice as big as this one on that side right. Then the ratio of the perimeters, meaning all of the outside added up on one compared to all of the outside added up on the other, is also going to be 2 to 1. That's it. Just 2 to 1. Yes, ma'am?
I was going to say, can you write that as like 2 to 1?
No, because we're going to use it in proportions. That's a very good question. We're going to have to set it up in like a fraction equal to a fraction and cross multiply, so we want to keep it as a fraction.
Okay.
Very good question though. Okay, anybody else? Good. Now, the ratios of the area, guys, what kind of units are areas? We've talked about this before. All areas and what kind of units? If we write feet, it'd be feet squared. Always square units. So to go from the perimeter to the area, you are going to square the numbers. You're going to square the numbers. That's it. You just square them. How do you know that? Because area is square unit. Every type of area, feet squared, inches squared, meters squared, all these are square units. So in order to change it from perimeter to area, you're going to square both the numbers, guys. This is all you do. 2 squared over 1 squared. What is 2 squared? 4. And what is 1 squared? 1. There's the ratio of the areas. The area of the bigger one is 4 times as big as the area of the smaller one. Guys, the ratio of the perimeters and the ratio of the areas is usually, not always, but usually not the same. Usually not the same. Anybody have any questions so far? Just on the concept of what I did, anything about it? That's just kind of like info. Okay, let's go to some problems, guys. Here we go. So your problems are going to look like this. They're telling you the figures are similar, so same shape, different sizes. It says compare the first to the second, so you're going from the left to the right. And you want to give the ratio of the perimeters and the ratio of the areas. Guys, first of all, how many answers are there going to be to this problem? 2. 2 answers. Okay, to get the ratio of the perimeters, you're going to start by just putting the relationship between the sides. 16 over 10. Grab your calculators, reduce it. It's that simple. Ooh, that was loud.
8 over 5.
What is it?
8 over 5.
8 over 5. Perfect. That is going to be the ratio of the perimeters. Just so you know what it is. Ratio of the perimeters. And then what do you do with both the numbers to find the ratio of the areas? Square them. That's it. Square them. 8 squared over 5 squared. 8 squared is what?
64.
Perfect. And then 5 squared is 25.
Wait, so it's all of this?
For this part, yep. Yep. And this is like the first 7 problems on your homework. That's it. This is that first 7 problems on your homework. Yep. Okay, and this is the ratio of the what? Areas. Good. Okay, guys, what way do we go from left to right? If we go left to right, what would the fraction be for the ratio of the perimeters? Which reduces to 1/2. Didn't even have to use a calculator for that for most y'all. Good. Ratio of the perimeters. Yep.
How would you put that in your question?
Absolutely. Type it in. 4, fraction button, 8 equals. Yep. That's guys, it's okay. It's just thinking about, like, you're not thinking about it like a regular fraction. You're thinking about it being some big ratio, big something else. It's fine. Ask.
Just divide the top number by the bottom number and we'll sort it.
You'll get a decimal, but then you just second arrow. You can do that too. Yep. Okay, then you take the numbers and you take the 1 and square it, and the 2 and square it. Guys, 1 squared is 1, 2 squared is 4. So that is the ratio of the areas. That means that the first one is 1/4 the size of the second one. The first one is 1/4 the area of the second one. So far, so good. Again, that's the first 7 problems on your homework. Yep, please. Oh, no. That's a very good point to bring up. This is not about the actual area itself. This is just their relationship. Thank you for asking that question. That's a very good question. We're going to be finding areas in a second. That's what we do next. So that's important that you know the difference between these two. We're not actually finding perimeter or area. We're just finding the relationship between those two amounts. So they don't have any units on them, and they don't have any feet, square feet, regular feet, whatever. That is a good question, because the next one is finding this. So here we go, guys. Okay. Again, they're similar. Same shape, different sizes. It says the area of one figure is given. Here's the area. Find the area of the other figure. So guys, the whole point is we are finding the area of this shape. And we're going to round it to the nearest whole number. We're following the directions, rounding to the nearest whole number. So guys, you start off the exact same way we did the other problem. Literally, the exact same process. We're starting with the relationship between the sides, which is going to be 40 over 26. Grab your calculators and type 40 fraction button 26 equals second fraction button. 20 over 13. Perfect. That is the ratio of the perimeters. Now we need to find the ratio of the areas. So we're going to do what to both these numbers? Square them. Perfect. Now I know 20 is 400. Oh, and I know 13. 13 is what, guys? Yeah, we got that one. Okay. So that's the ratio of the areas. So far, so good. It's the same. Y'all notice we haven't done anything different yet? This is the extra step. So we just did everything we did. Now we're going to add to that the second half of this, which is going to be to find the actual area. So the relationship is 400 to 169. All right, and guys, I went from left to right. So I'm going to put this 280 in here for the area. Where's that going to go? Ooh, I went from left to right. So over here, it's got to be left to right. Which one's on the left? A 280. And what do we put down when we don't know something? X. Guys, we've done tons of proportions. Cross multiply and solve. To cross multiply this, 400 times x is 400x. And then grab your calculators. It's a large number, just so you know. 169 times 280.
47,300.
Perfect. Then we are going to divide both sides by 400. Okay. Now, remember, you are rounding to the nearest whole number because that's what the directions said. What would that be? 118. And that would be, where's the unit? Meters squared. because this is the actual area of the shape. Okay. Okay, guys, if I ask you this question, what is the ratio of the areas in this picture? Which of these numbers is the ratio of the areas? It's the 400 over 169. What's the area of the new shape? 118 meters squared. And what is the ratio of the perimeters? The 20 over 13. Let's write it on here just so we have it. Ratio of the perimeters, ratio of the areas, and this is the actual area. I just want you to know what you've got. Questions, concerns, anything before I go to the next one? I think have I got two more? Okay, good. All this is all there is, guys. It's all the same stuff. There's not a lot to it. You just got to know the rules. Okay, here we go, guys. The next one is going to be triangles that are going to be similar to each other. Okay, so we start off with the ratio. Does it say to go? Aaron, walk through. Okay, it doesn't say anything. So if we have the arrow on this one, we're going to go from left to right. They don't tell you to go the other way, guys. You always go left to right. So in this case, we're going to start off with what fraction is our first fraction?
17.
Now, what about 17 over 24 is different than any of the ones we've done before? Yep, the ratio of the perimeters is right here because it does not reduce. Then we square both the numbers. 17 squared over 24 squared. Guys, what's 17 squared? 289. And I think 24 is like 576.
Yes.
Okay. And that's going to be the ratio of your areas. Okay, so what's the first part of my proportion over here? I'm going to have two fractions equal to each other. What do I put as the first one? Ooh, you got to be able to tell me that. Which one goes first, guys? The 289 over 576. The ratio of the areas is what we start with. This fraction is going to be the ratio of the areas. We are going from left to right. So we're going to go from left to right for the areas. So my first number on the other side is going to be 94. And we always put a variable when we don't know something. So we're going to put that x down there. And we're going to cross multiply. Now, when we cross multiply this, guys, the x times 289, there's nothing to calculate on that. It's just 289x. But on the other side, go in the other direction, you're going to have to cross multiply, and you're going to have to deal with, oh, I have two more after this. Y'all told me I had two more. I have three more. I have two more after this. Okay. Yeah. Okay, so this is going to be equal to what, guys? 54144. Okay. Divide both sides by 289. Remember that we are rounding to the nearest whole number. Try dividing it. Y'all agree? I just want to check the rounding. We're good on that? 187? Okay, so 187, that would be inches squared. Why would it be inches squared? Because this is the what of this shape? This is the area of the shape. The area of this shape would be 187 inches squared. Good. We got one last concept to talk about. It's just going backwards, guys. It's the same thing we did at the beginning, but going backwards. It's not a big deal. Don't make this harder than it is. Okay. Questions, concerns, anything? Don't forget we're on that weird schedule. We get out of here. What period is this? Second. We get out at 9:01. Just keep me kind of paying attention to the time. 9:01. Okay. Okay, guys. Here we go. Last two. So this is about finding the scale factor, the ratio of the perimeters for each one of these. We're starting off with their areas. We have to work backwards. Guys, listen to me. We have to work backwards. Before, when we started this, we took and we squared everything. When we have the area though, and we want to work backwards to regular units, guys, how do you undo squaring something? Square roots. So let's start off here. We're going from the left to the right. So it's going to be 220 5 over 81. These are the areas though, and to undo areas, to work backwards from areas, you are going to take the square root. So grab your calculators, we're going to take the square root of both these numbers. What is the square root of 225? 15. And what is the square root of 81? Ooh, but grab your calculators again, because this is not done, because this can reduce. Take it and reduce it, and it reduced down to 5 over 3. Not taking the square root again. Be careful, because I'm tempted to do that too. I was when I learned this. It's about reducing it like any other regular fraction. You would type 15 fraction button 9 equals second fraction button. Okay? This number right here is going to be the relationship between the sides. So you've got a scale factor that's going to be 5 over 3. This is going to be your scale factor. But guys, what did I say about the scale factor and the ratio of the perimeters? They're the same. So if you have the scale factor, then you also have the ratio of the perimeters. You're done. You've already done it. You just need to understand that they are the same amount. These two things are exactly the same number. So whatever you get for one answer, don't do anything to it, just put the same answer. So if we do this for the second one, going from left to right, it's going to be 64 over 100. We're going to take the square root of both. Well, I want to show you something, guys. Grab your calculators real quick. I want to show you something about this, because there may be some that would make it easier on the test to do, on the assignment to do this way. Guys, take 64 over 100 and type it in the calculator. 64 fraction button 100. You can also reduce it first and then take the square roots. No.
16 over 25.
Oh, you mean at the end.
Yeah.
Okay, you just went two steps. We're only going one. So when you reduce it down, it's going to be 16 over what? 25. And then once you have it reduced, then you can take the square root of both of them, and it's going to put it at 4 over 5. That's where you were at. Yeah, and then reduce it. It's the same thing. You can do it either way. That's what I wanted to show. Guys, you can reduce first, then take the square roots, or take the square roots, then reduce. I'll tell you that sometimes they have little weird things in them, like if they both have a pi or something in them, you want to cancel that out, so reducing first would be better. Now that means your scale factor is going to be what?
4 over 5.
But so is your ratio of your perimeters. Both of them would be 4 over 5. Okay guys, so today we have that